third-year MBBS student at Faber Medical College. She has 12 publications. Today's topic is data extraction and outcomes. Now, Dr. Omama will take over and start the session. Ma'am, please.
Thank you so much, Rafia. Assalamu alaikum, everyone. I'm Omama, and I'll be teaching you guys today how you're supposed to do extraction for your meta-analysis, right? So whenever you're given the task of doing extraction, so there are two types of data that you have to extract. One is the outcomes, and which is the most important one because you will be analyzing and reporting that data in your meta-analysis. And the second one is the baseline data, right? So, and baseline data is basically the patient data, which is given before the patient has been introduced to the intervention, right? Like, for example, there is a study in which a patient is being exposed to a certain drug, right? So the characteristics of that patient, which are noted down before the patient was exposed to that drug, are known as the baseline characteristics, right? While the outcomes data are reported after the patient has been exposed to the intervention. And one more thing you have to remember is that you have to do extraction on the Excel sheet. And yes, you have to do extraction separately for both the outcomes and the baseline data, right? So I'll show you guys a study so that you guys can understand what an outcome data is, what baseline data is, and so that you can extract them accordingly. So this is a study which I took out from PubMed, and it is a randomized control trial. Okay, so the study is on cardiovascular and renal outcomes with empagliflozin in heart failure, right? So the outcome of interest in this study is cardiac events, and the intervention is empagliflozin, right? And empagliflozin is basically an SGLT2 inhibitor, which is given for heart failure patients. So you can say that in this study, basically heart failure patients were taken and they were exposed to an intervention group, which was empagliflozin. And the outcomes that were assessed were cardiovascular and renal outcomes, right? Before we move on with the extraction and analysis, one thing that you should know is that as soon as you open a study on PubMed, right, on the right-hand side, you see some links. These links are basically full text links. Sometimes these links are open access. It means that you can simply access them without paying anything, right? And sometimes they are closed access, right? So this means that you either have to access them from Sci-Hub or you have to pay. In this case, this study is an open access, so I can simply click on the link. Yeah. Okay. So as soon as you open the full text of a study, the first thing that appears in front of you is the title, right? The title of the article. And after that, after the title, you have the abstract. And after the abstract, the actual full text begins, right? So this means that you will have the introduction section, you will have the method section, you will have the discussion, you will have the results section, then the discussion section, and then the conclusion, right? Okay, since I'm teaching you guys extraction today, one thing that you guys need to know is that in extraction, you're extracting two types of data. One is the baseline and the outcomes data, right? Both of these data will be reported in your results section. So whenever you're extracting data in your meta-analysis, what you have to do is that you have to go directly to your results section, right? So this is our results section for this study. Okay. Once you guys reach on the results section, there are certain tables in the results section. About 80 to 90. The first thing you have to do is that you have to identify where your baseline data is reported and where your outcomes data is reported in the results section. About 80 to 90% of the time, your table number 1 is the baseline characteristics, and table number 2 is the outcomes table. For example, in this study, our table number 1 is baseline characteristics, right? You can simply identify it by reading the captions, right? But sometimes this is not the case, right? For example, I'll show you guys another study. Yeah, this is. We'll go to the results section of the study. And yeah. So can you guys see that this is the results section? And the first table in the results section is the outcomes table. right? It is not the baseline table. So you have to make sure that the data, the table that which you are extracting the data from, you have to see whether it's the baseline data or the outcomes data, right? So once you've opened the baseline table, always make sure, okay, let's say if you're including about 10 studies in your meta-analysis, right? Let's say you've done literature review, you've done screening, and you finalized 10 studies for your meta-analysis, right? So what you have to do is that you have to open the baseline table. You have to make sure that all the studies which you are including in your meta-analysis should have at least two groups, right? It should not have less than two groups. Like there are single arm meta-analysis, but they are not that much beneficial and they do not have that much, right? There should be at least two groups. That is, it should be a double arm meta. One is the intervention group and the other is the control group. And this type of study is basically better because you're actually comparing two groups now. So that so once you're done with your whole meta-analysis, you're done with your extraction, you're done with your analysis. At the end of the study, you can comment, okay, which group was better, which drug was better for this particular disease, right? So you can actually comment at the end once you are done with all of this analysis and extraction and everything, right? So that's why it is always better that you should have at least two groups in your meta-analysis, right? Okay, so the first group is your intervention group, and the second group is your control group. Your control can either be placebo or it can be any drug other than placebo, right? It does not matter, okay, what your control group is. What matters is that your intervention group should be the same throughout, right? Let's say if you're including 10 studies in your meta-analysis, then all 10 studies should have the same intervention. For example, in this study, our intervention group is empagliflozin, right? And our control is placebo. So you should make sure that the rest of the 9 studies should also have empagliflozin as the intervention. And your control group, it doesn't matter. It can be placebo or it can be any other drug other than placebo, right? Do you guys know what placebo is? Can anyone tell me in the chat box what placebo is? So placebo is basically, it is a fake drug, right? And if it is a fake drug, it can either contain a sugary substance or anything else, which is basically given to a patient in place of actual drug, so that the patient does not know what drug he is being given, right? And it is given to ensure that there is no bias in the trial. So even the patient does not know whether he is being exposed to the intervention group or the placebo group or to any other drug, right? Okay. So the intervention in this case is empagliflozin. Our control group is placebo for this particular study. Okay. This N value written here, capital N, right? This is the sample size or the total population for the intervention group. That is the empagliflozin. And N, and this N is the total population for the placebo group, right? So if you add these two studies, if you add these two populations, right, you'll get the total population for your whole trial, right? So you have to carefully note down these values because you will be using these values later on in your extraction, okay? Okay, and Asha, one more thing. Do you guys see that here this is written, the empagliflozin is written in the intervention group, but I told you guys that this is the baseline characteristic table, right? And I told you guys that baseline characteristics are basically those characteristics of the patients before they were exposed to that particular intervention group, right? So even though it is written empagliflozin here, it does not mean that the patients have been exposed to that specific drug, right? These are the characteristics of the patients before they were exposed to the drug, right? Okay. Acha, the baseline table in different types of studies are generally similar. Let's say you have cohort, ICTs, etc. The general structure of the baseline characteristics throughout your study, throughout the different studies, is generally similar, right? Like you will be given the age, you will be given the sex, okay, female or male, you will be given the gender, okay, race may or may not be given, then region may or may not be specified. Okay, NIHA function class. What is NIHA function class? NIHA functional class is basically the classification used for heart failure patients, right? Since we are doing a study, since this study focuses on heart failure patients, so they have used NIHA functional class as the classification system, right? But if you are doing study on some other type of disease, let's say you are discussing renal diseases, right? You're studying renal outcomes, then you will be given some other type of classification, right? You may be given CKD classification, you may be given EGFR classification, etc., right? Or if you are studying some skin diseases, right? Then you will be given the class or classification or the scale which is used to assess that particular disease which you are studying in your meta-analysis, right? So what I'm trying to say is that, for example, this article is on heart failure patients, right? Then you will be given a scale or a classification system which is used to assess heart failure. You will not be given a scale or classification system which is used to assess skin disease or something else in this particular article, right? But if you're studying something else, if you are focusing on skin diseases, right? If your article or your study is focusing on skin disease or renal failures or some other disease, then you will be given classification systems or scales which are specific to that disease, right? In this study, we're discussing heart failure patients, right? We're discussing the efficacy of empagliflozin on heart failure patients. So that's why we're using NIHA function class. If we were discussing some other disease, let's say it was something related to renal, then you might be given some other classification, for example, CKD classification or EGFR classification. Or if you're discussing something regarding skin diseases, then you will be given a scale or a system of classification that is specific to that particular disease, right? So what I'm trying to say is that in a baseline characteristic table, those scales, those patient data will be given, which are specific to the patient population and to the disease which you're studying, right? If you're studying heart failure patients, then all the data that is relevant to the heart failure patients will be given, right? The system of classification will be given, which is used to assess heart failure patients. If you're discussing some other kind of disease, then the scale or system of classification specific to the other disease will be given, right? Okay. Now moving on. Achha, one more thing that you need to know is how the data is reported, right? How the values are reported. So there are several methods or several ways in which data is reported. It can either be reported in the form of whole numbers and percentages, in the form of means and standard deviations, and or in the form of medians, etc., right? So how do you guys identify or know, okay, whether a outcome or a variable is reported in the form of whole numbers or percentages or in the form of mean and standard deviation, right? So what you guys do is that, for example, do you guys see this female sex, right? Along with it, this is written number, and in brackets is written percentages. So this means that this particular variable is reported in the form of numbers and percentages, right? What does number and percentage basically mean? This means that 437 patients, 437 patients out of the 1863 patients in the empagliflozin group, which is our intervention group, were females, right? 437 patients out of 1863 were females, and the total percentage is written in the brackets. Similarly, 456 patients among the placebo group. The total population for the placebo group is 1867. Out of them, 456 were females. And again, the percentage is written in the form of brackets, right? The second way of reporting the data is in the form of mean and standard deviation, right? So how do you guys know, okay, whether a data is reported in the form of mean or standard deviation or not? So whenever you guys see a plus minus sign between two numbers, then you should know that that data is reported in the form of mean and standard deviation, right? So this data, you guys can see that this value is reported in the form of plus minus. This is reported in the form of mean and standard deviation, right? This is also in mean and standard deviation. Can you guys tell me, is systolic blood pressure reported in the form of mean or standard deviation or in the form of whole numbers and percentages? Anyone in the chat box? Good. Yes, great. You are right, Janita. Okay. And what about race? Is race given in mean and standard deviation or in whole numbers and percentages? Yes, good. Okay. Acha, one thing you have to make sure, I told you guys that you basically have to extract, you will be extracting this baseline data and you will be putting it on an extraction sheet, right? You will be putting it on an Excel sheet, Excel sheet. So what you have to do is that you have to make sure, for example, if you're including 10 studies in your meta-analysis, right? And in this study, let's say NIHA function class. NIHA function class is reported in the form of whole numbers and percentages. What you have to make sure is that in the rest of the studies, you have to make sure that you report the data in the form of whole numbers and percentages, right? Make sure that you're reporting the data in one format, not in different formats, right? It's not like you can report one variable in the form of whole numbers and percentage, and the second you're reporting in, and for the second study you're reporting it in the form of medians or standard deviation, etc. Right? Make sure that your reporting method is in one format. And how do you decide whether you're going to report the data in the form of means or standard deviation, or you should report it in the form of whole numbers and percentages? You have to go with the majority, right? For example, in 10 studies, 7 studies report the data in the form of mean and standard deviation. What you will do is that you will report the data in the form of mean and standard deviation. But if majority of the studies are reporting the data in the form of whole numbers and percentages, you will report the data in the form of whole numbers and percentages, right? And for the remaining studies, what you will do is that you will convert those values into the format which is reported by most of the studies. I'll send the conversion tool. I'll not show you how you're going to convert those things, okay? Because there's a because that is very simple. I'll be sending you a calculator in the IRC groups. You can simply put the values. So you can simply put the values in it, and that calculator will automatically calculate it for you, right? Okay. Then what is left? Baseline table. Okay, then I'll show you guys an example of how a baseline table is. Okay. Can you guys see my screen? Can you guys see the extraction sheet? Sorry, the baseline sheet. Okay, great. So the general pattern or the general structure of the baseline table is generally similar, right? You can use this same baseline table with certain changes, and you can put it in the, and then you can use it for your own meta-analysis, right? But the overall structure is generally the same. So the first column in your baseline table is basically the type of study, right? Let's say you're including 10 studies in your meta-analysis. You have to specify whether the studies you're including in your meta-analysis are they cohorts or are they clinical trials? And if they are cohorts, you have to specify whether they're prospective or retrospective. Similarly, if they are randomized, if they are clinical trials, you have to specify are they randomized or non-randomized, right? For example, this study, Pelika et al. 2005 is retrospective. Okay. Similarly, these last two studies, they are randomized control trials. Okay. So in the first column, you have to specify what is the type of study. Okay. Then the second column. The second column is basically for the study ID. The study ID is basically the name of your study, name of the article, name of the study, which you will be using in your extraction, in your analysis, and in your manuscript, etc. Right? You will be naming your study. And how are you going to do that? Is that you're going to use the last name of your first author. Last name of your first author along with the year of publication, right? Last name of first author along with the year of publication. Okay, let's use this study as an example. Can you guys tell me what will be the study ID for this particular study? Can you tell me in the chat box? Yes, good. Pecker et al. 2020. You can write et al. Or you can just write Pecker 2020, right? Both ways are correct. Okay, great. So first column is the type of study. Let's first write it here. Pecker 2020. And our study is randomized control trial. So I'll write here RCT. Okay. Now, the third column is basically you have to write what is your intervention. What intervention are basically you're given, right? In this case, can you guys tell me what is our intervention in this study? Good, yes. Fatma, you're correct. Ashmat, you're correct. You're right. Yes. Good. Empagliflozin is our intervention block. So what I will do is that I will write, I can simply copy it. Let's see. Oh, okay. So this is our intervention. The fourth table is for the control group. You have to specify what your control is. If your control is placebo, you'll write placebo over here. If your control is any drug other than placebo, then you're going to write the name of that particular drug, right? You guys see that in this study, all the intervention groups were same. The intervention groups were same. And similarly, all the control groups were also same, right? So you have to make sure that your intervention groups are same. But if control groups are different, it does not matter. It's okay. Okay? What you have to make sure is that intervention group should be same. The control group in our case is placebo. So I'll write placebo. And how I got to know my control group is placebo? I checked it from the baseline table. Here's my baseline. Yes. So intervention is empagliflozin and control is placebo. Then moving on. Total number of patients. Total number of patients. I told you guys in the baseline table, this N represents the total population of the intervention group. And this N represents, that is 1867, represents the total population of the placebo group, right? So if you add both of these values, you'll get the total population or the total sample size for the whole trial. So what you are going to write in this total population, you're going to add these two values, 1863 and 1867. And then you're going to write the total population here. Okay? Then patients in the intervention group, so you're going to write here 1863. My intervention group had 1863 patients and my control group had 1867, right? Okay. Then moving on. We're done with the first column, which was type of study. Okay, you have to mention whether your study is cohort, whether it's a clinical trial, etc. Then you're going to write the study ID, which is Spec et al. 2020 in this case. Then you have to write the name of the intervention group. Then you have to write your control group. Then you have to write the total population. You're going to add these two, and then you're going to write the total population over here, right? And then you're going to write the population of the intervention group, control group, and after that you have the follow-up time. Do you guys know what follow-up time is? So follow-up time is basically the time starting from when the patients were recruited, right? So it is basically starting from the patient recruitment till the end of the study. This is the follow-up time, right? And I told you guys that majority of the times, I mean, all the data which you are supposed to include in your extraction is reported in the results section, right? But follow-up time may not be reported in the results section. So if you do not find the follow-up time in your results section, what you have to do is that you have to move on to the methods. Okay, you'll go to the methods section and you'll see if whether follow-up time is reported in your method section or not, right? So follow-up time is basically the time from when the study started, from when the trial started, from when the patients were recruited till the end of the study. This whole period is the follow-up time, right? So in this study, wait, let's see what is the follow-up time here. Okay, the study started in April 2017 to November 2019. And okay, so the study started in April 2017 and it was completed in April 29, 2020, right? So it took almost 4 years, right? So this is the whole duration time, right? The whole follow-up time. Wait. Yeah. Oh, you have also been given the follow-up time in the form of medians, right? The median duration of follow-up was 16 months, right? Okay. So in the studies, the follow-up time has been reported in the form of in two ways, right? One way is that they have given you the whole time duration, right? From when the study started until when the study ended, right? Can you guys tell me why why some studies give you a follow-up time in the form of mean? Like why do they give you an average follow-up time? This 4 years is the time for the whole study, now. So why have they given a mean value? Sometimes some studies don't give the overall value; they give um, just a mean value. Yes, good, good, Mahma. Yes. So basically, what happens is that sometimes the patient might not have stayed in the whole trial process, right? Sometimes the patient might have dropped out, or some might have been recruited at a later date, right? So that's why most of the studies they report data in the follow-up time in the form of mean or means, right? So one more question. How do you guys decide? Like for example, in this study, they have given a whole duration time, right? And they have also given follow time in the form of means or medians, whatever it is, right? So how do you guys decide, okay, for example, in this baseline table, how do you guys decide okay, whether you're going to write the follow time, like the whole duration, or you're going to write the medians? So what you're going to do is that you're going to follow the majority rule. If majority of the studies report the follow-up time in the form of whole duration process, then you're going to report it in that format. But if most of the studies report the data in the form of um, will report this data in the form of medians or means, then you will um, report that your follow-up time in the extraction sheet in that format. Okay. Okay. Moving on. We're done with the follow-up time. The next column is overall mean age, right? So overall mean age, let's say, where is it? Yeah. Okay. Overall mean age. Can you guys tell me, again, this data is reported in the form of mean and standard deviation. How I got to know that? From the plus minus sign, right? Can you guys tell me whether is this 69.9 and bracket made is written 14.8? Can you guys tell me, is it reported in the form of mean or standard deviation, or is it in the reported in the form of whole numbers and percentages? Great. It's in mean and standard deviation, not in whole numbers and percentages, right? So again, remember, majority of the times, this is a fact that wherever you see the plus minus sign between two numbers, that is mean and standard deviation, right? There is no denying that. But sometimes mean and standard deviation is reported in the form of brackets too. How will you know that this value is reported in the form of mean and standard deviation? Is that, for example, let's say this 69.9 and 14 point bracket measure is written 14.8, right? This was written alongside a variable or outcome, let's say blood pressure, right? And along with that blood pressure, it it is written that the blood pressure is reported in the form of mean and standard deviation, right? It will be written along with blood pressure. Okay, this particular outcome, this particular data is reported in the form of mean and standard deviation, right? So what you have to do, for example, if you're extracting the data, right? You know, you're the one who's reading the studies. You actually know, okay, this data was reported in the form of mean and standard deviation. But the person who's doing analysis, right? He does not know this, right? He will assume okay, you have reported, yeah, you have extracted the data wrong in a wrong way, right? So what you have to do is that you have to mention here. You have to mention that the data you are extracting is in the form of mean and standard deviation, right? So the person who's doing analysis later on, he knows that this data was also in the form of mean and standard deviation, right? Okay. The next column, then the next is males and females. You have to write the male and female population. Asha. One important thing to remember is that you do not have to report both males and females. Okay, how many males were there and how many females were there, right? You just have to report the population of just one gender, right? And that is males. Majority of the times, like whenever you're making baseline table for your meta-analysis, you have to report the gender in the form of male population. You do not report in the form of female population. One of the reasons is because majority of the studies, right? Majority of the trials, majority of the studies um, express or report their gender in the form of male population, right? Majority of the studies report their population in the form of male population. However, that is not always the case. For example, in this study, our gender population is reported in the form of female, right? Female sex is given. They have given how many patients were females, right? So they have given 437 patients out of 1863 were females. What you're supposed to do, for example, uh, let's say you're including this study in your meta-analysis, right? You're not going to report the data in the form of females. What you're going to do is that using the female population, you're first going to calculate the male population. And then you're going to add the male population into your baseline table, right? And the reason why we enter the male population is because majority of the trials recruit more males, right? For example, if they're conducting a trial and their sample size is 1,000, majority of the patients who agree to taking part in that particular trial, majority of them are males, right? So that is why majority of the times trials report their patient population in the form of female or their gender in the form of male population, right? They do not report female population, and it is understandable. Let's say there was a clinical trial, okay, and 50% or let's say 60 out of 100 total population, 60 out of 100 patients in the intervention group were male. Can you guys tell me how many were females? Good. 40. Good. So it's common sense, right? You don't have to report both things. Just report the gender population in the form of male, right? Just write K 40. Let's go back to the baseline table. Okay. So these two columns are for the intervention group. These two columns are for the control group. The total shows the total population of the intervention group. And this total shows the total population of the control group, right? Okay, what are events? Events basically tell you how many patients out of this total population were males, right? How many patients out of the in the intervention group were males? In this case, 43 patients out of the 99 patients in the intervention group were males. Similarly, 129 people out of the total 239 recruited for the control group were males. Similarly, they have reported the data for female population. Okay, 56 out of 99 patients were females. If you add 56 and 43, you'll get 99, right? So just report this. Just report the data in the form of males. Remove this, right? You don't have to. Okay, I'll just delete it. You don't have to write the female population. Report the data in the form of males, right? And if let's say, for example, in this study, you're not given the male population. You're not given how many patients were male. You're going to calculate it. You're going to then put it in the extractions. Okay? Sure. In the same way, you're going to extract all the variables that are written, that are given in the baseline table, right? All these variables, you're going to extract it in the same way you have extracted the data for the male population, right? Okay. Do you guys notice these empty spaces? These blank spaces? These blank spaces. Again, these blank spaces. So these blank spaces are basically, they show this particular characteristics, this particular variable, let's say hyperlipidemia, was not reported by these three studies, right? Hyperlipidemia was not reported by these three studies. So what you're going to do is that you're going to leave it blank, and then you're going to write NR. This means not reported. This means that this particular variable was not reported by this study, right? In all these blank spaces, you're going to write NR, okay? So it's easy. All the characteristics that you find in the baseline table, okay? First we wrote the age, then the gender, then if race is given in other studies too, then you may write it. And if race is not mentioned in those studies, then you're not going to add it to the baseline table, right? Then region, I have functional class, etc. Okay, in this way, you're going to extract all the data, and then you're going to start putting it in the extraction baseline sheet, right? Okay. Let me see if anything else is left from the baseline table, and then we'll move to the outcomes part. Okay, we're done. So we're done with the baseline table. We're going to move to the data extraction part. Okay. This is basically our outcome sheet. I told you guys in results section, your table number 1 is the baseline table, right? Majority of the time, around 80 to 90% of the times. Your second table is the outcomes table, right? So what you have to do when you're making the outcome sheet, you open the Excel, okay? You'll have a blank page. What you're gonna write in the first column, study ID. The same way you did in the baseline table, right? You made the study ID table. You can simply copy paste it from here, right? You can simply copy it and then paste it in the extraction sheet, right? Okay. So our first study was Packer et al. 2020, right? So this is our first study. What you're going to do is that the first step is that you have to identify the study. You've identified the study, that is, you have written the name of the study. Okay. The next step is that you have to write all the outcomes present in that particular study. Like I'm going to open the study Packer et al. Okay. This is the study Packer. This is the baseline table. I close it. I'm going to go to the outcomes table. This was my table number 1. I'm going to go to the table number 2. This table number 2 is, can you guys see table number 2? This table number 2 gives the outcomes. Okay. This is the outcomes table. Achha. So what you're going to do is that these are all the outcomes. Okay. You're going to write or copy all these outcomes. You're going to copy this. Okay. You're going to copy hospitalization for heart failure. Okay. You're going to paste it here in your extraction sheet. Can you guys see hospitalization for heart failure? Similarly, you're going to copy all the outcomes that are reported in this Packer et al. Study. And then you're going to keep on pasting it here. For example, the second outcome, I'll paste it here. Then third one will go here. Okay? Fourth one will go here. Okay? So you're going to copy all these outcomes. All of these outcomes, you're going to copy them. Okay? And then you're going to paste them on your extraction sheet. So you're going to have a sheet in which you'll have study ID, Packer et al. 2020, and then you're going to have all these outcomes. Okay. The next thing which you have to do is that you have to make 2 columns. One is the intervention group, then the control group. Okay. In the intervention group and the control group, you have to see, for example, hospitalization for heart failure. Okay. You have to go to the outcomes table. You have to see whether hospitalization for heart failure, is it reported in the form of whole numbers and percentages, or is it reported in the form of mean and standard deviation, right? So in this case, hospitalization for heart failure is reported in the form of whole numbers and percentages, right? So what I will do is that I will go to the extraction sheet and I am going to write events and total. Okay, I'm going to write events and total. And then I'm going to extract that. I'm going to write events and total for the intervention group and for the control. Okay. Okay, so I have 246 patients out of 1863 presented with this outcome, right? So 246 patients out of the 1863 reported this outcome in the intervention group. Similarly, 342 patients out of the placebo group, which is 1867, reported this particular outcome. So what I'm going to do is that I'm going to write this data in my extraction sheet. Total population was 1863 for the intervention, and for control it was 1867. And then my some events for control group was 342, and for prevention it was 246. Yeah, 246 and 342. This is 246. Okay. So this is how you're going to extract your data. You're done with your first outcome. Okay. You're done with the extracting data for your first outcome for your first study. Okay. In the same way, you're going to keep on extracting data for all the outcomes which you have written for your first study. Okay. You're going to report the second outcome. You're going to enter the data for the second outcome. Then for the third outcome, you're going to check the outcomes table. You're going to extract it from there, and then you're going to add it on the your extraction sheet. Okay. Once you're done with your first study, okay, let's say your data is reported in the form of mean and standard deviation, right? Let's say your data is reported in the form of mean and standard deviation. What you will do is that you will again make two columns, intervention and control. Then in intervention, you're going to make three columns, right? One column will be for mean, second column will be for standard deviation, and third column will be for the total, right? Similarly, in the control group, again, you will have three columns, three further columns. One will be one will be mean, second will be standard deviation, and the third will be total. What you're going to do is that in the same way, you're going to copy the mean, okay? Let's see, this value. Mean slope of change in EGFR. This is reported in the form of mean standard deviation, right? So what I'm going to do is that I'm going to copy 0.55, which is the mean, and 0.323 is the standard deviation. Okay. So I'm going to copy 0.55 and I'm going to write it in my, add it to my extraction sheet. Okay. Let's say this is the second outcome, which is reported in the form of mean and standard deviation. I'm going to wait. Let me just add the third column. Copy this. See. Third sheet columns, right? So this will be SD. This will be mean. Okay. So you're going to write the mean values in this column. You're going to write the standard deviations in this. And this total is the total population in the intervention group. Okay. Similarly, you're going to do the same for the control group. So you're going to write the mean value here. You're going to write the standard deviations in this column and then the total in this column. Achha, once you're done extracting the data for your first study, Pecker et al. 2020. Let's say you're done with extracting the data of adding all the outcomes, reporting all the outcomes for your first study. What you're going to do next is that you're going to move on to the second study. But how exactly are you going to extract the data for the second studies? And how are you going to add it into the extraction sheet, right? So what you're going to do is that, let's say, this second study, Pi et al. 2006, right? This study, acha, one thing you should keep in mind, okay, let's say this was my first study, right? And it reports around, let's say, 15 outcomes. Okay, let's say it gives 15 outcomes. Will my second study, it is not necessary. Okay, the next study, this another study which I'm including in my meta-analysis will have all these 15 outcomes, right? It may or may not have these outcomes. It may have either maybe 5 outcomes might be in common, maybe 10 or maybe 7. Okay, all the outcomes will not be the same. Okay, so what you're going to do is that, let's say your second study also reports hospitalization for heart failure, right? It also reports hospitalization for heart failure. What you're going to do is that you have already written this outcome, right? You have entered the data for the first study. For the second study, what you're going to do, let's say 36 patients out of the total 80 patients in the intervention group presented with this out, right? And in the control group, let's say 50 out of 100 patients in the control group presented with this outcome. Okay. In this way, you're going to keep adding the data for hospitalization for heart failure for all the studies in which it is being reported. Let's say this third study does not report this out. What you're going to do is that you're going to leave it blank, or you can write NR, okay, which means not reported. Similarly, let's say these two studies also don't report this outcome, hospitalization for heart failure. You're going to leave it blank, okay. This is how you're going to do it. Okay. Again, I told you guys the outcomes reported in your first study and in your second study may or may not be the same. Okay, let's say there are some outcomes in your second study, which is Pi et al. 2006. It may report, let's say it's reporting some outcomes which was not reported in your first study. Okay, it's reporting some new outcomes. Let's say it's reporting an outcome. Wait, let me open some other random study. Okay, I'll write it myself. Okay. Let's say your second study is reporting an outcome, which is adverse events. Okay? And adverse events was not reported in your first study. What you're going to do is that you're going to go to the end of your extraction sheet, right? All these outcomes were given by your first study. What you're going to do is that all the outcomes, all those extra outcomes reported by your second study, which were not reported in the first study, you're going to you're going to add them at the end, right? You're going to copy this. Control C. B. What you're going to do is that you're going to write that out. Let's say your second study gave an outcome, reported an outcome, adverse events, which was not reported by the first study. You're going to add adverse events at the end of your extraction sheet, right? In the same way, you're going to add all those extra outcomes which were reported by your second study but not reported by your first study. Okay? Okay. And then you're going to add, what you're going to do is that you're going to leave the first space blank because this outcome was not reported by your first study, right? And for the second study, you're going to write the values. Let's say 20 out of 50 patients and 30 out of 100 patients. 20 patients out of 50 in the intervention group reported this outcome, and 30 out of 100 patients in the control group presented with this outcome. Okay? That's how you're going to make the extraction sheet. Let's say in the third study, you find more outcomes which were not present in the first study or in the second study. What you're going to do? Again, you're going to go to the end of the extraction sheet and you're going to add it here. Okay? Let me copy it again. See? And let's say what will be the output? Let's say it's EGFR, okay? Let's say it was not reported by the first two studies, okay? You're going to add it at the end, and then you're going to leave the first two spaces blank and write the data for the third, okay? So this is how you make an extraction sheet. Let's see. No, Fatma, you make, if, let's say, if there are different adverse events, let's say if there are different adverse events mentioned, right? Let's say if there are different, let's say if there is constipation or what do we some lung issues or whatever, okay? If there are different adverse events mentioned, then you are going to write that as separate, okay? You're not going to write that as a collective under the adverse events. If let's say constipation or vomiting or etc., whatever the adverse events are, let's say if they are reported by more than 3 studies, okay? So what you're going to do is that you're going to make a separate column for that, okay? You're not going to report that under adverse events. I gave you guys, I wrote adverse events just as an example, okay? I wrote adverse events just as an example. Let's say the study reports only adverse events. It does not report, it does not specify, okay, what kind of adverse events, right? It has just written adverse events. That's why I wrote adverse events as an app. But if it has specified what type of adverse events there were, then you're obviously going to write make separate columns for them. Okay, you're going to write separate extraction sheet, and you're going to extract separately the data for those outcomes. Okay. Uh, okay. How to do studies? Acha. Okay, I'll summarize. Okay, Tuba, I'll summarize. But before summarizing, I'll answer Ahmed's question. Ahmed, I told you guys at the very beginning, okay, whenever you're reporting a data, whenever you're reporting anything, okay, whenever you're extracting the data, let's say there are 10 studies which you're including in your meta-analysis, and you're reporting, extracting the data for an outcome. Let's say that outcome is death from any cause, right? It is death from any cause. Your outcome is death from any cause, and it is reported in all 10 studies. I told you guys in the very beginning, okay, how you're gonna report that data, in what format you're gonna report that data depends on the majority rule. If majority of the studies are reporting that data in the form of mean and standard deviation, you're gonna report the data for the rest of the studies in the mean and standard deviations too. But if majority of the studies are reporting in the form of whole numbers and percentages, you're gonna report that in the form of whole numbers and percentages. Let's say 7 studies have reported in a specific format, right? While the remaining 3 studies have reported the data in a different format. What you're going to do is that you're going to convert the way the data is reported in the 3 studies into the format which is being reported by the 7 studies. And the conversion process, how you basically do that is that you're going to use a calculator. I'm going to send the calculator in the IRC groups. Okay, you can easily use it. I'm not going to show you how you use that, okay, because it's very simple. You can do it yourself. Okay, you're just going to write the values. It will tell you, okay, what value you have to write, what data you have to enter, and then it will going to convert that. Okay. Moving on. Acha. Summarizing everything. So we've learned how to make a baseline table. Okay. I told you guys, okay, if let's say in meta-analysis, there's a task of literature review, there's a task of screening, okay? There's a task of writing results section, etc. But you're given the task, you're given the task of doing extraction. So when someone gives you extraction, they give you the task of doing extraction. They expect 2 things from you. One, to extract the data for the outcomes table, for the outcomes data, and the second data is for the baseline, right? The baseline data is reported in the table number 1. Majority of the times, the outcomes data is reported in the form in table number 2. Then we learned how to extract the data from the baseline table into the extraction sheet. I told you guys you're going to use this format for the baseline table. Okay? You're going to write the type of study, you're going to write study ID, the intervention, control, okay, number of patients. Okay? I told you guys you are supposed to make the extraction sheet on an Excel. Okay? You're not going to use anything else for extraction, just Excel. Okay? And then you're going to write number of total populations, intervention group. Okay? I told you guys in gender, you have to write you have to report the data in the form of male population, not the female one. If the studies report data in the form of female population, convert them into male population and then report that data. Okay? And I told you guys, always make sure, the data which is being reported, make sure, whether it's in the form of mean standard deviation or in the form of whole numbers or percentage, right? Make sure the format or the in which you're reporting the data in your extraction sheet should be the same throughout. Not in, you can take it like this. For example, one outcome can report the data in mean standard deviation, and the second outcome may report the data in the form of whole numbers and percentages, right? But you have to make sure, I'll show you guys an example. Let's say hospitalization of heart failure. Okay, this is the outcome. Make sure all these 20 studies report the outcome in whole numbers and percentages. And if we have a study, if we have majority of the study, let's say 7 studies report this particular outcome in mean and standard deviation, then make sure all the studies for this particular outcome report the data in mean and standard deviation, right? If I say you have to make the format consistent, this does not mean all these outcomes have to be reported in the form of whole numbers and percentage. No, what I'm saying is that if one outcome, this particular outcome, cardiac specific mortality, should be reported in the same format throughout the studies. Hospitalization for heart failure should be reported in the same format throughout the studies, whether it be mean of standard deviation or events or total or any other format. Okay. Um, okay, Aparna. So basically, what you have to do is, let's say, one study. Again, you're again gonna go with the majority. Okay. If you want to report an outcome, okay, when you're doing extraction, what you're gonna do is that what you usually do is that you write all the outcomes for the first study, then you write all the outcomes if there are extra outcomes, right? If there are extra outcomes, you write them at the end of study, okay? You enter the data, and for the third study, you enter the data in these outcomes, and if there are any additional outcomes, you add them into the at the end of the study, right? But the thing that decides whether the outcomes that you have written or added into your extraction sheet, whether they should be analyzed or whether they should be reported in your actual meta-analysis, okay? The person who is doing analysis, it's his job to see whether the studies, let's say this outcome, EGFR rate, okay, it is reported in 3 or more than 3 studies. Then you will report this outcome, you will include this outcome in your meta-analysis, right? But if this study, you ask if one study has reports adverse events and the other in other specifies what type of adverse events there are. So if majority of the studies report, if more than 3 studies report adverse events, then you're going to include that as enough, right? And if more than 3 studies include, uh, more than 3 studies specify what type of outcome, what type of adverse event it is, then you're going to report that too. Okay. Outcome variables are different in different studies. What do you mean by that? Michelle, let's say if only one study shows that not. Yeah. If only one study shows adverse events, you'll not report that. Okay. Listen, your job is to do, your job is to make the extraction sheet, right? Your job is not to analyze. Your job is to make the extraction sheet. And in extraction sheet, you have to extract all the possible data, all the possible data, all the possible extractable data that you can find in the studies. It is the job of the analysis, if the one who's doing analysis, or maybe even you can do that. After you're done with extraction, you can simply highlight. For example, let's say this particular outcome, this was reported in more than 3 studies. You can simply highlight this. You can highlight it as yellow. Let's say this was study, this outcome was not reported in more than 3 studies, or at least 3 studies. Don't highlight this. So it will be easier for the person who's doing analysis to decide which outcomes to analyze, right? Your job is to extract all the data. Okay. Okay. So we're done with baseline table. We're done with extraction. Let me see if there's anything left. Then I'm going to teach you guys how you're supposed to extract data from graphs, and then we're going to end the session. Okay. And if you guys have any questions, you can send those questions in the feedback forms. Okay, I'll answer them in the. I'll respond to them. Okay. Mm, okay. Now moving on to the. So we're done with baseline table. Okay, how you're supposed to make the baseline table, how you're supposed to extract. I told you guys that whenever you're extracting data, the data is always reported for extraction. That is the outcome data, and baseline data is always reported in results section. Sometimes some outcomes may not be. Whenever you open a study, always seek whether that study has supplementary files or not. Okay. Sometimes there are some outcomes, data for some outcomes are not reported in the main manuscript. They are reported separately in the supplementary files, right? So make sure, check whether that study has supplementary files or not. Okay. The second thing is that sometimes the data is not reported in the form of numerical values. Like in this study, you were given table, right? You were given a table. You can easily extract the data from this table, right? But sometimes the data is given in the form of graphs. So how do you extract data if the data is given in the form of graphs? Okay. For that, we use an app which is called as Plot Digitizer, right? Okay. Wait, let me just. You're going to go to Google, okay? You're going to click on Plot Digitizer online app. Okay. And this is what will be showing on your screen, okay? So I don't have any studies at this moment, which so that I can show you specifically, but I have some graphs, screenshots of some graphs which I'll show, and I'll show you guys how you're supposed to extract data from it, okay? Acha. Whenever there are graphs, there are two types of data which you can extract. The data can either be reported in the form of events or total, or it can be in the form of mean and standard deviation. Okay. How you're going to do that is how you're going to use Plot Digitizer is that you're going to open the study. Let's say it's this study. Let's say there are some graphs here. Okay. There are some outcomes which are reported in the form of graphs. Okay. What you're going to do is that you're going to go to the graphs and you're going to take the screenshot. Okay. Go to the graphs and take a screenshot. After you've taken a screenshot, crop it so that only the graph is shown. Okay. I will then save that file. After that, go to the Plot Digitizer. Click on this button. Do you guys see the arrow? Click on it. Okay. Now you guys can upload the screenshot of the graph which you took from the study. Okay. Let's say it's this one. Okay. Is everyone following me up till here? One. Hashmat, you just include the baseline characteristics, which are, let's say, common, which are reported in majority of the studies, right? You can't possibly like enter all the baseline characteristics, right? Just enter the major ones, okay? Think the ones which you think should be mentioned in the baseline characteristics table. Okay. Ashitaiba, what I did was that, let's say you're extracting a data from a study, okay? But that outcome, data for that outcome, let's say in this case, we have progression-free survival. This is the outcome and it is reported in the form of percentage, right? But the data is given in the form of graphs. I can't possibly extract the data by just looking at it or by assuming things, okay? I can't just simply say, okay, let's say, and this on the x-axis, these are weeks, right? I can't simply say, okay, let's say if I want to find the progression-free survival at 2 weeks, yeah, I can't just guess or say, okay, it's 90 or it's around 80, right? So in order to find accurate, extract data for these outcomes accurately, we use an app which is called Plot Digitizer, right? You're going to go to Google, you're going to open Plot Digitizer, okay? And as soon as you open, okay, let me do it again. Let's do it. Wait. Let me open it again so that you guys can see. You're going to go to Plot Digitizer, open it. You guys see an arrow here? Okay. What you're going to do is that you're going to go to your study. Let's say this was my study. And this study reported an outcome in the form of a graph. I cannot extract that data by looking at it, okay, or by any other method. What I will do is that I will take a screenshot. Take a screenshot of that graph, crop it so that the rest of the page is not showing. You have only the screenshot of that particular graph. You're going to save it. After saving it, go to Plot Digitizer. You see this arrow here? Click on it. Then select the screenshot which you took. Okay. Select the graph and then upload it here. Can you guys see all this? Are you guys following me till here? Okay, moving on. You guys see these 4 dots? X1, X2, Y2, and Y1. Let's just revise. X1, X2, Y1, and Y2, right? So after opening this plot digitizer, once you've uploaded the graph, what you're going to do is that you're going to do collaboration. What is collaboration? Collaboration is basically that you're going to just take these dots, X1, you're going to drag it, right? And you're going to place it at the lower limit of your x-axis. Okay. Similarly, you're going to take x2, drag it, and place it on the upper limit of your x-axis. Okay. Then take y1, place it at the lower limit of your y-axis. Okay. Take y2, place it on the upper limit of y-axis. Okay. Once you're done with placing the dots, can you guys see this here on the right hand side, x-axis, and then on the then you have y-axis, you have x1, x2. What you're going to do is that x1 is your lower limit for x-axis, right? You're going to write 0 in it because 0 was your lower limit for x-axis. Upper limit for x-axis was 24. I'm going to write 24 here. 24. Similarly, for y-axis, it was 0. You guys see? This is 0. And the upper limit is 100. I'm going to write 100 over here. Okay? What I did was, there were 4 points, 4 dots, x1, x2, y1, y2. I dragged x1, placed it on the lower limit of x-axis. I dragged x2, placed it on the upper limit, which is this one, of x-axis. Then I took the 2 dots for the y-axis, placed it on the lower limit, y1 on the lower limit of y-axis, and y2 on the upper limit of the y-axis. Okay, so this graph is basically for the progression-free survival. Can you guys see here? Progression-free survival. Progression-free survival. This is an outcome which was reported for I think it was reported for metformin or something. I don't exactly remember, but yeah. And these were the weeks, right? So let's say in my extraction sheet, there were 7 studies or 8 studies. Let's say 5 studies. They reported the data. They reported this outcome, progression-free survival, for 2 weeks, at 2 weeks, right? 5 studies reported progression-free survival at 2 weeks. The remaining 4 studies did not report progression-free survival, neither in the outcomes table nor in the graphs, right? But this study did report the progression-free survival, but it did not report it in the form of table. It reported in the form of graph. And that is why I used the app Plot Digitizer. Okay, once we're done till here, these were the weeks, right, along the x-axis. What I'm going to do is that I'm going to move. Do you guys see the graph here? On the right hand side, you guys can see the zoomed view. Okay. What I'm going to do, and can you guys see these numbers? This x20, it's currently written 24.11, and for the y, it's written 95. What I'm going to do is that I'm going to move till I reach 2 here. Okay. Till this number turns into 2. I don't need a 24 here because I want to find the progression-free survival at week 2. This means at x-axis, it should be 2, right? So when this number becomes 2, I'm going to click at that point, right? In this graph, can you guys see the numbers are changing? 0.40, now it's 0.51. Can you guys see the numbers changing? As I move through the graph, numbers are changing, right? when I get a 2 at the x, yes, so I got a 2. What I'm going to do is that I'm going to click here. You guys see this left hand side? As soon as you guys click here, these numbers appear on the left hand side. This 2 basically represents the number of weeks, which is 2 weeks. And this basically gives you the y-axis, progression-free survival. But this is not the complete data. Okay? This is still raw. What you're going to do is that you're going to take this 85, the value which you get along your y-axis. You're going to take that value and multiply it with your sample size. Right? You're going to take that value, multiply it with your sample size, and divide it with the upper limit of your y-axis. I'm going to repeat it again. Take the value for y-axis, which you got here, which is 85. I'm going to multiply it with my sample size. Let's say my sample size is 50. I'm going to multiply 85.4 with 50. And then I'm going to divide it with the upper limit of my y-axis. What is the upper limit of my y-axis here? It's 100. I'm going to divide it with 100. Okay? And that final value which I get will be the progression-free survival at week 2. Okay? Let's say if my upper limit here was 1, then I will simply multiply 85 with 50 and then divide it with 1, which is the same as multiplying 85 with this 50. Okay? Did you guys understand? Wait, what is the use? Okay, I'll repeat, don't worry. I'll do it again. Okay, I'll do it again. Okay. I'm doing it one more time. Okay. Everyone please pay close attention. Okay. On the left hand side, you guys see nothing. It's just x written here and y written here. There are no values here. Okay. On the right hand side, you guys see x-axis, x1, x2, y-axis, y1, y2, right? You guys see these values? And this is basically a maximized view. Okay? A magnified view. Okay? This is basically a magnified view. If I move my cursor here, you guys can see the magnified view on the right hand side. Okay. So what I did is that I uploaded the graph on a plot digitizer. Why did I upload the graph on a plot digitizer? Because I cannot determine. Okay, let's say, some of you were asking, okay, why did I take the progression-free survival at week 2, right? I'm going to explain it to you through the baseline table. Sorry, the instructions. Let's say this is the output, right? I'm going to write it here. Progression, the survival at week 2. Okay? Let's say this was the outcome. This was the outcome which was given, which was reported by majority of the studies, by let's say 5 studies. You're including 10 studies in your meta-analysis. Okay? 5 studies report this outcome. Progression-free survival at week 2. One study, the 5 studies report this outcome in the form of table. So what you did was that you simply extracted the data and you entered it into the extraction sheet. 4 studies did not report this outcome. But there is one more study which did report this outcome. It reported progression-free survival, but it reported in the form of a graph. So there is data for this outcome in that study, but you can't extract that. How are you going to find whether the outcome, how are you going to find the events for it? How are you going to find the data for it? You can't just simply look at the graph and tell, no, it might be around 85 or 80 or something like that, right? You can't just assume things. You have to calculate it through a proper calculator. Okay? And for that purpose, we use plot digitizer. You guys understand this? We can't calculate the values visually by ourselves through a graph. We have to calculate it through an app, and one of the apps is the plot digitizer. Okay, so how do you use that? As soon as you upload the screenshot, right? As soon as you upload the picture, you get 4 dots. Y1, 4 dots appear. Y1, Y2, X1, and X2. First step was uploading the screenshot. Second step is that you have to collaborate these dots. How are you going to do that? Again, look closely. Take X1, drag it to the lower limit of X-axis. This is the lower limit of X-axis. Can you guys see the magnified image on the right-hand side? Right. Then you're going to take X2 and drag it to the upper limit of X-axis. You're going to do the same with Y-axis. Is that you're going to take this Y, place it on the lower limit of Y-axis. Y2, place it on the upper limit of Y-axis, okay? After placing the dots, what you're going to do is that you're going to write, okay, what was your limit? What was the lower limit? Where did you place X1? The lower limit of X-axis, right? What was your lower limit? 0. Write 0 here. Then what is X2? Where did you place X2? At the upper limit of X-axis, right? What you're going to do? What was the upper limit of X-axis? 24. Write 24 here. Then moving on. Y-axis. Where did you place Y1? At the lower limit of Y-axis, which is 0. Right? 0 here. Where did you place Y2? At the upper limit of Y-axis. You're going to write, what was the upper limit of Y-axis? 100. You're going to write 100 here. Okay? Now, once you're done with placing these dots, okay, once you're done with placing the dots in their specific positions, what you're going to do on the right-hand side, do you guys see these values? There's written X 24.8 or Y. You guys see as I move my cursor on the graph, these values change. You guys see this? The values are changing. Now it's 15, now it's 14, now it's 13, 10, 9, right? The X value shows X gives 18. I told you guys, okay, these were weeks, right? Along the X-axis, they have written weeks. This is 1 week, this is 2 weeks, this is 3 weeks. Let's say if the progression-free survival reported by the studies was at 16th week, then I will obviously take the I will obviously plot the graph at the 16th week. I will not take it at 2, right? So at what week you take that data, at what week you extract the data depends at what week majority of the studies are reporting that data, right? Let's say 5 studies are reporting the data at week 2. Then you are going to extract the data for week 2. If they are reporting the data, if they're reporting the outcome for progression-free survival at week 16, what you're going to do is that you're going to move along the graph and you're going to see, okay, when this X turns into 16, it's 14, now it's 15. As soon as it changes into 16, I'll stop there. Yes, now it's 16. It's okay. You can be a little decimal points above or below 16, but try, okay, it's exactly 16, okay? Now, once I've reached to 16, this means, okay, it will give me the data. It will give me the progression-free survival at week 16. Why am I taking it at week 16? Because I'm giving you guys an example. Okay, let's say the progression-free survival was reported for the other studies at week 16. It's not asking me for week 2 or week 3 or week 4. It's asking me, okay, what was the progression-free survival at week 16? I'll take the Data for week 16. I'm going to click here. As soon as I clicked here, you guys see these values appear on the left-hand side again. They were not there initially. In the x side, I see, with the x-axis, I see 16. These are the weeks. With the y-axis, I got 27. Again, what did I tell you? What you're going to do? You're going to multiply this 27 with your sample size. Multiply the 27 with the sample size and then divide it. Divide it with the upper limit of your y-axis. Let's say the sample size in this case was 50. I'm going to multiply 27 with 50 and then I'm going to divide it with, what is my upper limit in this case? 100. I'm going to divide it with 100. Let's say if my graph did not have 100, it had 1. The upper limit was 1. What will I divide it with? 1. You guys get it now? And the final value which I will get will be the progression-free survival. Now this rule applies to any outcome. What if there is no numbering on the, no, there has to be some numbering on the graph. If there is no numbering on the graph, then you cannot extract the data, right? Sample size will be given. Aisha, sample size, let's say, Aisha, I did not show you guys something. I'll give you guys an example. This is the baseline table, right? Aisha, I told you guys, no, this is the outcome table, right? One thing I forgot to mention is that the total for a particular outcome, let's say, this is total, right? This is the outcome, hospitalization for heart failure. If the total population in the intervention group in the study is 1863, right? If the total population is 1863, it does not mean it is necessary to all these outcomes that this 1863 is for all these outcomes, right? This 1863, it does not mean that this 1863 is the total population for all these outcomes, right? For example, in this outcome, death from any cause, not this one, onset of new diabetes, right? Onset of new diabetes in patients with pre-diabetes. It is written 71 out of 632, right? So they have given you a number. They have given you 71 out of 632 patients. So this means that for assessing this particular outcome, they did not take 1863 patients. They did not take the whole 1863 of the intervention group, right? But they took only 632 patients. So when you're extracting the data for this outcome, you're not going to write 1863 in the total. What you're going to write? 632 in the total, right? But if, let's say, for this outcome, number of hospitalization for any cause, they have not written any total number of patients in the intervention group, right? Here, along with 1364 for this particular outcome. If the total number is not written along with the outcome, then it means that this is the total number of population for this particular outcome. But if it is mentioned along with it, that you're going to write this total. In this case, you're going to take 1863 in the as the total, okay, for this particular outcome. But let's say in the outcomes table, even in the outcomes table, you're not given the sample size. Let's say there is no sample size given in the, or no total population given in this whole. Let's assume that in this outcomes table, there is no total population. There is no total sample size given. But in the baseline table, they gave you the outcome. They gave you the total sample size, right? They gave you the total sample size. Then you're going to take this sample size as the total. Okay. But if a separate sample size is mentioned for each outcome, then you're going to take that sample size which is mentioned along with that particular outcome. Do you get that? I'm going to show you a graph for mean and standard deviation. Okay. This was for outcomes and events and total, right? For dichotomous outcomes, not for continuous. So for continuous outcomes, that is mean and standard deviation. I'm going to show you another graph. Okay. okay, just one last graph and then we're gonna end the session. Okay, this was for events in total. I'm gonna give you guys another graph for mean and standard deviation. Okay. Let's go to the plot digitizer again. Wait, I don't know how to delete it. Okay, I'll just open it again. Plot digitizer. Yeah. We're on the plot digitizer page again. Wait, this time I'm not gonna tell you. You guys are gonna tell me okay, what we're gonna do starting from here. I've opened the screen. What am I gonna do next? Yes, good. Great. So click on the arrow. You guys are right. I'm gonna click on the arrow. Next, you guys said, okay, I'm gonna upload the image. I already have taken the screenshots before. These are screenshots from my from some previous studies, not me. Okay. So what I'm gonna do is that I'm gonna click on the screenshot, then upload. This is the new graph. Okay. Okay, so this graph is for mean and standard deviation. Asha, how are you guys gonna know okay, whether the graph which is okay, you guys can ask me a question. You guys can this question can come into your mind. Okay, how do you know okay this graph? How can you say okay, this graph is for mean and standard deviation and not for events in total? Like I said, okay, the previous graph was for events in total, right? How can we decide okay, this graph is for mean and standard deviation or not? So you have captions along with the graph, right? So it will be mentioned in the captions. Okay, these dots represent this, these lines represent this, the bar graph represent this. Okay, it is written in the captions of this particular graph. Okay, so I have not taken the screenshot of that, but it is mentioned along with the graphs. Okay, this line represents this. Okay, so bar graphs are usually for mean and standard deviation. Again, what am I gonna do next? I'm gonna do collaboration. I'm gonna take the x1, x2. Okay. Can you guys see here I don't have any value for x. I don't have any value for x, right? They have given me randomization, but this is not let's say a numerical value, right? What numerical value I have here? 32 and 38. What I'm gonna do is that I'm gonna take this x1, drag it to 32, place it here. I'm gonna take x2, drag it to 38, place it here. This is my lower limit for x-axis and this is the upper limit, right? Because I don't have any other numerical values for the x-axis. Now tell me in the chat box, what do I do with the y values, y dots? Yes, good, Manahil. Yes, Aisha, Fatma, Abdul, yes, all of you are correct. Mohammed, good. I'm going to take y1, place it on 3, take y2, and place it on 7. Okay. Till here, the whole procedure was same as we did for the events and tool, right? Till here, the procedure is same. What I'm going to do next is a bit different. Okay. So this study is for, this graph is for blood glucose level, right? And there are two groups. The orange bar graph gives me the values for metformin and placebo gives me values for, sorry, the blue chart gives me the values for the placebo, right? In this graph, both the groups have been represented in the same graph, right? And I have to find the blood glucose level for metformin group at week 32. Let's say there is an outcome, like the rest of the studies have reported an outcome of blood glucose level for metformin group at week 32. But this particular study did not report the outcome in the form of table, right? So, and it gave me a graph. So what I will do is that I will take this graph, okay, I will place it in the plot digitizer. I will extract the values from using plot digitizer. Asha, please pay close attention, okay? This line, do you guys see this line? This black line? This is the mean. And how do I know okay, this is the mean? It was written in the caption, okay? The caption which was written along with this graph, okay? it specified that this line, this central line was mean. I did not assume it from myself. Okay? I did not know it from the start. The captions told me that this was the mean. Okay? Similarly, you guys can also, okay, when you're doing extraction, okay, it will be easy for you guys too. You guys can simply read the text which is written along, which is given along with the graphs, okay, and you guys can see okay, which line represents what. So what I will do is that I will write 32 here in x1. In x2, I'll write, this is, I place the dot x2 on 38, right? So I'll write 38 here. In y1, I'll write 3. y2, my upper limit for y-axis, I'll write 7. Okay? Now, what I'll do is that I'll move this cursor till I get a 32 at my x-axis. I'll move this cursor till I get a 32 here at the x-axis. I'll move it. Okay. I got a 32 here, right in the center. I'm going to click here. Okay. So this is the mean, right? This is the mean. And these are my, can you guys see these lines? These are the upper limit and the lower limit, right? These are the upper limit and the lower limit for this particular metformin group, okay? And the difference between the mean, if I subtract the upper limit, the mean from the upper limit, I'll get the standard deviation, okay? If I subtract the upper mean from the upper limit, I'll get the standard deviation, right? So first I specified, I wrote what my upper limit was, sorry, what my mean was, which is 32. Then I'm gonna click on the upper limit, but at exact 32 again. You guys see on the left hand side, I've got two values. The first 32 is for the mean, this one. The upper one is the 32. This is for this one. Okay. I got a 4 here, and this 32 is for the upper limit. By subtracting these values, okay. So if I subtract this mean value, the mean value which I got along the y-axis for this mean value, I'm going to subtract it from the y value which I got from the upper limit, right? I'm going to subtract 4.8 from 6, right? I'm going to subtract 4.8 from 6 and I'm going to get the standard deviation. Is it clear? What I did was that I placed the cursor at 32 weeks for metformin group. I placed it at exact 32. I got the y value for it. Then I went to the upper limit. These were the upper limit and the lower limit. If I subtract the mean from the upper limit, I get the standard deviation, right? When you're entering data in the standard deviation, what do you guys need? You guys need three things: mean, standard deviation, total, right? So I need to find the standard deviation. And how do I find that? Is that I'm going to subtract the mean value from the upper limit. How do I find the upper limit? Is that I'm going to click on the upper limit at exact 32, right? Because I clicked the mean value at 32, right? I'm going to do the same for the upper limit. And then I'm going to subtract this 4.8, which is the mean, y-axis for mean. I'm going to subtract it from the upper limit. And then the value which I'll get will be my standard deviation. Okay? I'll show you guys another example. Okay? I'll do it again for the 38 week. Let's say they're asking for an outcome. Let's say they're asking outcome for the blood glucose level at week 38. I'm going to move my cursor till I get 38. Yes, 38 at the mean. I got 38 at mean. What I'm going to do is that I'm going to move to the upper limit, go to 38 and then click here. You guys see? This 38 is the mean. And this 38 is the upper limit. This is the y value for the mean, and this is the y value for the upper limit. I'm going to subtract 4.5 from 5.6. The value which I get, I think so it will be 1.1 or maybe, I don't know. Fine. You guys can calculate that yourself, okay? And the value which you'll get will be the standard deviation. Is it clear? This is how you do extraction for your continuous outputs. Yes, upper limit minus mean will give you the estimate. So this is how we do extraction. Minahal, that was for events in total. That was for dichotomous outputs, right? But this is for continuous outputs. Okay. There are separate methods to deal with different formats, different types of data. You can't use the same method for all the types of data sets, right? So for events in total, what we did was that we used the y-axis, we multiplied it with the sample size, we divided it with the upper limit, right? But in this case, we need to find the standard deviation. Our goal is to find the standard deviation. And how do we find the standard deviation? In the previous one, we did not find the standard. The value which we got was not standard deviation, right? But in this case, we have to find the standard deviation. How do we find that? We find that by subtracting the y value which we get for the mean from the y value which we get from the upper limit. No, we're not going to multiply and divide. Acha, Gayatri, I took 32 weeks and 38 weeks. We'll take from 3. Gayatri, there is no 3 on the x-axis. This 3 you see here, this is on the y-axis. This is not on the x-axis, right? If there were a 3, okay, and if there were a 3 here, and if the outcome sheet, if there were outcomes from other studies which had reported this data, this blood glucose level at week 3, then obviously I would have taken the data, I would have calculated the SD at week 3. But there is no week 3 at x-axis. This 3 is along the y-axis, okay? So Mohammed, you want me to summarize it again? Can you tell us what size dichotomous outcome? Yes, Omna. You're asking what if the rest of the studies showed at 35 weeks, right? And this study, let's say, gives you a graph and it's in 32 and 38 weeks. Then it does not report the data for 35 weeks. You are not going to take this. You're not going to do extraction from this graph because this graph is not showing you the data for 35 weeks, right? You're not going to extract it then. The rest of the studies take it at 35 and this gives you only 32 and 38, you're not going to extract it. Okay? Asma, the mean and SD is written like whenever there are images. Have you ever opened a study? Whenever you open an article, right? There are images, there are tables, and there are certain captions written along with it. There are certain text written below that graphs or the image or the table. If you read those lines carefully, then they will specify whether the graph is in mean or events for events or total, whether it's for dichotomous outcome. There will be certain hints, right? For example, in this case, there was written this value is written in mean, and the upper limit, the line in the box gives you the mean value, and the two upper horizontal lines, the upper and the below horizontal lines, gives you the upper and lower limit. So this was written in the captions along with this graph, right? So that is how I got to know, okay, this is mean and SD. And bar graphs, they usually give you mean and SD. May vary if there is no. Guys, wait. Actually, guys, I think so. This session has prolonged a bit too much. Okay. What I will do is that if you guys have any questions, you guys can write them in the feedback form, and then I will respond to them in the feedback form. Okay, I'll just summarize the whole session within, I think it will take about 10 minutes. Okay, I hope 10 minutes में I am able to summarize it. So what we did, we learned that if you're given the job to do extraction, always remember two types of data you have to extract: baseline data and the outcomes data, right? Baseline data you have to extract. Table number 1 is baseline data. Table number 2 is the outcomes data. Make sure that the studies you're including meta-analysis should have at least two groups. One is the intervention, the other is control. There may be more than two groups, but that is a separate thing. Okay, first you should learn the basics. Okay, then we moved on to, we learned how to make the baseline table. I'll show you guys the baseline table again. Okay, we wrote the study. First column is for type of study, then study ID, total number of, then you have intervention, control, number of patients. We wrote the total number of patients by adding the intervention and the control group populations. Then the follow-up time, I told you, okay, how you're supposed to write the follow-up time. How are you going to decide whether you're going to write the whole duration time or the mean duration time? It will depend in what format majority of the studies are reporting that data. Okay, then the age, okay, then the males, I told you guys, you guys only have to specify just one gender, and that is males. You do not have to enter the data for females. And then moving on to the outcomes, that is the extraction sheet. I told you guys, what you're gonna do, write the study ID again. This is your first study. Then what you're gonna do, you're gonna go to your study, you're going to open the outcomes table, and you're going to copy all the outcomes that you find there. Copy all the outcomes that you find there. Okay? And then you're going to paste them in the extraction sheet. After pasting them in the extraction sheet, what you're going to do is that you're going to write, let's say these are all the outcomes that I copied from the first study. I'm going to write, enter the data for all these outcomes. If the outcome is reported in the form of is a dichotomous outcome, that is, it is reported in the form of mean, not mean, events and total, right? Whole numbers and percentages. What I'm going to do is that I'm going to enter the data. I'm going to write to make two columns, events and total, for intervention control. But let's say the outcome is continuous. That is, it's reported in the form of mean and standard deviation. What you're going to do is that you're going to make three columns: mean, SD, and total. You're going to write mean in the mean column, SD in the SD here, and total here. Let's say I had an outcome, progression-free survival at week 2. It was, I had included 10 studies in my meta-analysis, right? 4 of them gave me progression-free survival at week 2. The rest of the 5 did not give me. There was one study which did report this data, but it reported the data in the form of graph. What I will do, I will write the total. Total will be given in the outcomes table. If it is not specified in the outcomes table, what I will do, I will move to the baseline table. I will write the total population for the intervention group from the baseline table if it is not given in the outcomes table. Next, moving on. I will find the SD. SD, how I will find, I told you guys how I'm going to calculate that those values from the graphs using plot digitizer, right? I told you guys how we're going to calculate values, extract values from the graphs for events and total, and for the what do you call it? Mean and SD, right? Is everything clear? There is another type of graph. Do you guys want me to show you, or do you guys want to end the session? There's one more graph which I want to show you guys if you guys want. Okay. If anyone wants to see the extraction for that, okay, they can stay in the meeting. If anyone wants to leave, they can leave. Okay. Where is that graph? Let me. Okay, I'll just show it to you from the images. Okay, I'll not extract it, but I'll just show it to you. Do you guys see this graph? So this graph was again for mean and standard deviation, right? In the captions, in the text written along with this graph, it was specified that this central line. Do you guys see these lines? The midline. This midline is mean, right? The midline. These all midlines are the mean value. This was written in the text which was written along with this, which was given along with this graph. So they told me that the central line was the mean value. And these upper lines, do you guys see these vertical lines? Okay? These are the upper and lower limits. This is the upper limit and this is the lower limit. So let's say if I want to find the mean and SD from this graph, what am I going to do? I'm going to use the same method. What I'm going to do, I'll just show it here. Okay? I get 4 points. Now, whenever I upload this on the plot digitizer, I'll get 4 points. I'm going to place x1 here, x2 here on 100, then y1 on 0 again, and y2 on 0.8. Then what I'm going to do for mean and SD, what did I tell you guys? You're going to place it on, let's say if I want to find it for, let's say these are days, right? And if they're asking me to find, what is this? Insulin initiation, right? If they want to find the time for probability of insulin initiation at day 75, what I'm going to do is that I'm going to move along this line, okay? And when I get a 75 on this midline, let's say I got a 75 here, I'm going to click it. This is the mean. As soon as I click it, I'll get the y value for this mean. And what am I going to do next? I'm going to click on the upper limit, but at 75 again. I'm going to click at the upper limit at 75 again. I'm going to get y values for the mean and for the upper limit. I'm going to subtract the mean value from the upper limit, and then I'll get the standard deviation. Okay? So this graph is again for mean and standard deviation. This one was also for mean and standard deviation. And this one was for events and tools. Okay? That's it.